Hi everyone, myself Jyoti Prasad from R&D Engineering College. Today I am going to explain about analog to digital circuit flash type comparator, flash type ADC. So first of all, we have two types of converters: A to D converter, D to A converter. So basically, if you see what is the necessity of converters when we are measuring any one quantity in any biomedical applications, we need to save some one of the quantity. Then we will convert that analog value to first digital, and we will process and store those one. Since we want to get any things back, then we will convert that quantity from digital to analog. So basically, we have two ADCs. If you see ADCs analog to digital converter, we have two types of converters: direct type ADC, indirect type ADC. So first of all, direct type ADC is nothing but input signal will compare with internally generated equivalent signal. So nothing but V reference. Majorly, we have four type of ADCs: flash type, counter types, tracking or servo converter, successive approximation type converter. Whereas coming to the indirect type of ADCs, which we call it as indirect integrating type, here it will do in indirect manner. First the input will be converted into linear function of time or frequency, then then to digital. So such type of indirect type of convert A to D converters are charge balancing and dual slope. Basically, we will see the single slope also. Think dual slope is the next version for overcoming the challenges in single slope. First, we will see this flash type comparator. So like I said, the successive approximation and integration type ADCs are the most commonly used A to D converters. The direct type ADC is the simplest one is a parallel type comparator or flash type ADC. Flash ADC. This is the simplest and fastest one, but expensive technique. This circuit consists of eight resistive divider network and eight op-amp comparators and one priority encoder of type 8 to 3. So if I want to show elaborately, see the eight comparators are there, and a resistive network is there provided with V reference. All these resistors are of equal value R, and we have a priority encoder of 8 to 3, 8 input lines, 3 output lines. So priority encoder, basically if we have both three things are high, y2, y1, y0, then it will give priority to the MSB. Then even though the other two are present, the y2 will be taken into account, the output will be 1. According to that, it will give priority to the MSB, which is having most value. That will be given priority. That's why we'll call it as priority encoder. So whereas coming to the highlights of this flash type ADC, the circuit consists a resistive divider network and 8 op-amp comparator and one priority encoder of 8 to 3. And at each node of resistive divider, we will compare the voltage with input. See here, if we see this particular circuit diagram, at each comparator we have one of the input is analog input. Here we have given one input for every comparator is VA, analog input. The other input is V reference plus VR. So basically we are giving plus VR. So after passing through one resistor, basically it is 7 by 8 VR here. So after passing through one resistor, it will become 6 by 8 VR, nothing but 3 by 4 VR. After passing one more resistor, it will become 5 by 8 VR. Then 4 by 8, nothing but half VR. Next 3 by 8 VR. After passing through each resistor, the voltage, the VR will get down, it will decrease. And since all the resistors of equal value, the voltage available at all nodes is equally divided by VR. So like I said, each comparator will have two inputs. One is analog input. So that analog input will be compared with node voltage. See here, this node voltage. Here, this node voltage. So at each point, that node voltage is compared with the input signal. So if we want to see the comparator is compares with two values. For example, here VA is the analog input we are comparing with VD node voltage. So if VA is greater than VD, the output is 1. VA is less than VD, the output is 0. VA equal to previous, both are equal means previous value it will take. So here, so whenever this value is there 7 by 8 VR, then this comparator will get output 1, the remaining comparators are 0. So this will give input to 8 to 3 encoder, and hence the output will be Y2. If I want to show the operation, so when the input voltage is, see from the bottom we can come, so 7 by 8 VR to VR. So here, VR to 7 by 8 VR. If this is in the range, X7 will come. So X7. So that voltage is available, and each all other things will be 1 on. So like I said, when X7 is there, then the equivalent binary for X7 is 111. So that will come. So which bit is highest one, that's equivalent value will come as an output. So here, even though the all other ones are there, here the highest one is MSB is this one X7, that equivalent binary will represent here. So whereas coming to the next any if we take any one other level, 3 by 8 VR to 4 by 8 VR. So 3 by 8 VR to 4 by 8 VR means this is a fourth comparator. So then the fourth bit, from for the fourth bit it will take. So fourth bit is 1, third bit is 1, second bit is 1, first bit is 1. So we have this one is having highest priority. So this binary number will come as an output for x3 x311. So likewise, the encoder output will be generated. So hence that particular level of voltage will convert into a digital value. So this is the operation of flash type of ADC. So coming to the advantage of this one, this high speed conversion time will be there in the order of 100 nanosecond or less, and the conversion time is limited by two components. What are the means? Comparator. First, conversion time depend upon comparator, then thereby 8 to 3 encoder. The drawbacks are, the main drawback is nothing but if number of bits increases, then number of comparator will increases. So number of comparators required for almost double for each bit added. So what we have seen is for 3 bit. If I go for 4 bit, that the almost comparator will gets doubled. So in which manner means, for a 2-bit ADC, 3 comparators required. For a 3-bit ADC, 7 comparators up to 7. For a 4-bit up to X15 it is required. So almost getting doubled for each bit increment. Each bit is increasing. Thank you.